Hello everyone. Today's topic is hybridization of atomic orbitals. What is hybridization? Hybridization is the concept of mixing atomic orbitals to form new hybrid orbitals. The process helps to explain the shapes and bonding properties of the molecules. Types of hybridizations. There are 5 types: sp hybridization, sp2 hybridization, sp3, sp3d, and sp3d2 hybridization. Let's talk about hybridization one by one. First, sp hybridization. sp hybridization for linear molecules, bond angle is 180 degrees. You can see sp hybridization, 2 letters S and P. The meaning is one s orbital mixed with one p orbital to make 2 sp hybrid orbitals. Because number of orbitals we mix, 1s, 1p, 2 orbitals, then we need to make 2 s orbitals. This type of hybridization results linear arrangement with 180 bond angle. For example, beryllium chloride. Let's talk about the steps one by one, how hybridization, the mixing of atomic orbitals, is in this process. First, take beryllium. Beryllium configuration is 1s2, 2s2. So if we write the valence shell orbital diagram, 2s2 electrons, and in the same shell there are 3 empty 2p orbitals. But for the beryllium, no electrons in 2p. Second step, electron promotion to 2p. One of the electron in 2s promote to 2p orbitals. Next step is now s and p, one s orbital and this occupied p orbital mixed together. We called hybridization. 2 orbitals mix, they form 2 hybridized orbitals. These hybridized orbital we call sp. The remaining 2p orbital as blank. S orbitals are spherical in shape. P orbitals are dumbbell in shape. These S spherical in shape and P dumbbell in shape orbitals mixed together, they form hybridized orbital sp. They are completely different shapes. One lobe is large, the other lobe is small. These 2 sp hybridized orbitals now on the beryllium atom. Hybridized orbitals then overlap with chlorine's 3p orbitals to form 2 BeCl bonds in both sides. BeCl2 linear molecule, it is 180 degrees bond angle. Talk about sp2 hybridization. sp2 hybridization for trigonal planar bond angle is 120 degrees. sp2 hybridization, 1s orbital and 2p orbitals mixed together. For example, BF3, boron trifluoride. Let's start from boron. Boron configuration is 1s2, 2s2, 2p1. If you draw an orbital diagram for valence shell, 2s2, 2p1. Next step is promotion. One of the electron in 2s orbital we promote to one of the p empty orbital. So after promotion electron, the next step is orbital mixing. So mix orbitals. How many orbitals we need to mix? sp2, 1s and 2p orbitals with 3 sp2 hybridized orbitals form and the remaining 2p orbital. These sp2 hybridized orbitals now on the boron atom. Initially s orbital and then 2 p orbitals, px and py, combine to form hybridized orbitals. Hybridized orbitals are on 3 corners of an equilateral triangle. These 3 sp2 hybridized orbital on boron then overlap with 2 p orbitals of fluorines. Then they form BF3 trigonal planar with bond angle 120 degrees. Let's talk about sp3 hybridization. This is for tetrahedral 109.5 degrees. sp3 hybridization, you can see s1s orbital and 3 p orbitals needs to mix. For example, like CH4 methane. Let's write the configuration of carbon. It is 1s2, 2s2, 2p2. If we draw the molecular orbital diagram, 2s2 and 2p2. So let's promote one of the s electron to empty p orbital. Now in sp3 hybridization means 1s and these 3 p's mixed together form 4 sp3 hybridized orbitals. These 4 hybridized orbitals now on the carbon. You can see these are the orbitals we mix. 1 spherical s orbital, 3 p orbitals px, py and pc. P orbitals are dumbbell shape, s orbital is spherical shape. So after mixing all 4 orbitals together, we can get 4 sp3 hybrid orbitals. These hybrid orbitals are at the corners of a tetrahedron. sp3 hybrid orbitals now overlap with hydrogen's 1s orbitals to form CH bonds, 4 CH bonds on methane CH4. Tetrahedral bond angle is 109.5 degrees. sp for trigonal bipyramidal shape. There are 3 types of bond angles: 90 degrees, 120 and 180 degrees. A3D means 1s orbital mixed with 3 p orbitals and 1 d orbital. For example, PCl5. Start with phosphorus. Phosphorus electron configuration. The outer shell, or we call valence shell configuration, 3s2, 3p3. So if we draw the orbital diagram for outer shell, 3s2, 3p3, and there are 5 d orbitals in the same shell. Now next step is electron promotion. One of the electron in 3s promoted to the empty d orbital. Next, orbital mixing. 1s orbital, 3 p orbitals and 1 d orbitals mixed together to form 5 sp3d hybridized orbitals. The remaining 4 d orbitals empty and all 5 sp3d hybridized orbitals occupied with 1 electron. Now on the phosphorus atoms, all 5 sp3d hybridized orbitals overlap with 3 p atomic orbitals of each chlorine to make 5 p Cl bonds. You can see on this structure, 3 p Cl bonds are on the plane. They are in the corners of a triangle. These are we called in equatorial positions. The other 2 chlorines, the top chlorine and the bottom chlorine, they are in axial position. We consider the Cl, phosphorus, Cl, bond angle is 180. And if axial is phosphorus and equatorial, bond angle is 90 degrees. And equatorial, central phosphorus and equatorial, bond angle is 120. So there are 3 types of bond angles in PCl5. Let's talk about sp3d2 hybridization. sp3d2 hybridization is octahedral geometry. There are 2 types of bond angles, 90 degrees and 180 degrees. sp3d2 hybridization meaning is 1 s orbital mixed with 3 p orbitals and 2 d orbitals. For example, SF6. Let's start from sulfur. Sulfur electron configuration is 1s2, 2s2, 2p6, 3s2, 3p4. So valency shell is 3s2, 3p4. Let's draw orbital diagram for valency shell. 3s2, 3p4, and same shell there are 5 d orbitals with empty electrons. Next step is electron promotion. One of the s electron and one of the p electron promoted to 2 d orbitals. Now we have 3s, 3p orbitals and 2 occupied d orbitals. Next step, orbital mixing. Here to mix 1s, 3p's and 2d orbitals. So after mix 6 orbitals, we can make 6 hybridized orbitals sp3d2 and the remaining empty 3d orbitals. These 6 sp3d2 orbitals now on the sulfur atom. They overlap with 2p atomic orbitals of 6 fluorine atoms to make SF. There are 6 SF bonds. So here bond angle is 90 degrees and 180 degrees FSF bond angle. Geometry is octahedral. Let's discuss what we learned so far, the summary of hybridization. sp hybridization, the orbitals mixing S and P, the geometry is linear, bond angle 180 degrees. BeCl2 is example. sp2 hybridization, 1s and 2p orbitals. Trigonal planar 120 degrees. BeCl3 is example. Third one, sp3 hybridization for tetrahedral geometry. 1s and 3p orbitals mixing together to give 109.5 bond angles. Example, methane CH4. Fourth type, sp3d hybridization. S 3p orbitals and 1d orbitals. The geometry is trigonal bipyramidal. There are 3 types of bond angles present. 180 bond angle for axial, central axial, and 120 bond angles for equatorial axial, equatorial bond angle, 90 degrees for equatorial, central atom, equatorial bond angle. Example, PCl5. Next type, sp3d2 hybridization. 1s, 3p orbitals and 2d orbitals. This is octahedral geometry. There are 2 types of bond angles, 90 degrees and 180. For example, sulfur hexafluoride, SF6. Now let's talk about ammonia and water. You can see NH3 and H2O, both are sp3 hybridization. 1s and 3p orbitals mix together to form 4 sp3 hybridized orbitals. 4 hybridized orbitals are nitrogen and oxygen. On ammonia molecule, 1 sp3 hybridized orbital occupied by a lone pair electron. So this lone pair repelled NH bonding electrons, decreasing the bond angle less than tetrahedral bond angle 109.5. This is trigonal pyramidal shape. In water molecule, there are 2 lone pairs. 2 lone pairs further repels OH bonding electrons, further decrease tetrahedral bond angle. This is bent shape. I hope now you have understanding how to go through the hybridization process with examples. Thank you all for watching.